Unit 6.4, Other Methods of Proving Triangles Congruent. So far, we have learned that we can prove that triangles are congruent by side, side, side. If all three sides of one triangle equal all three sides of another, then they are congruent by side, side, side. Side angle side, if two sides and the included angle of one triangle equal two sides in the included angle of another, then we say they are congruent by side angle side. And then we had angle side angle, which was two sides and an included angle of one triangle equal two sides and an included angle of the other. Today we're going to learn two more ways to prove they are congruent. Those new ways are angle, angle side, and hypotenuse leg, which will give us a total of 5 ways to prove that two triangles are congruent. When we think about angle side angle, we're talking about two angles and an included side. When it's angle angle side, we're talking about two angles and a non-included side. So the sides that are equal to each other are not included between the two angles that are equal to each other. Okay? So here we go with angle angle side. If two angles and a non-included side equal two angles and a non-included side, then they're congruent by angle, angle, side, and we read it angle, very next side when you look at the marks. So if we look at this, we've got this angle is equal to this angle. The very next angle after that one is equal to the very next angle after that one. And the very next side after that is equal to the very next side after that. And so we have angle, angle, side in that order, equal angle, angle, side in that order. Notice that the side was not the one included in between the two angles. Had that congruent side been between there, it would have been angle, side, angle. So everybody understand the difference in angle, angle, side, and angle, side, angle. Okay? Now, in the next, well, let's just go back to this picture. So angle A was named first. It was equal to angle D, so D would have to go first. Angle B is named in the middle, and it's equal to some angle over there that we hadn't really figured out yet. We're going to kind of hang on to that. Angle C and F are the same. C was last, so F goes last. There's only one angle left in this triangle, and it's E. Therefore, B must be mapped to E. There's a theorem, that says if two angles of one triangle are equal to two angles of another, then the third angles are equal. So we could conclude that B is equal to E by that. Or we could say, since the triangles are congruent, angle B is equal to angle E because corresponding parts of congruent triangles are equal. A couple of different ways that we can use to conclude that angle B is equal to angle E. Okay? Now, we know that BD is equal to itself by reflexive property. Using that little piece of information, we could say that these are congruent by angle, angle, side. Angle A is equal to angle C. Little b on of the left one and little b on the right one correspond, and the little d's correspond, so that's the congruency. Once we know this too, this is 2 out of the 4 things from the isosceles triangle theorem, so we also could have by the isosceles triangle theorem said those are equal, thus concluding this is the angle, vertex angle bisector. So again, because of the isosceles triangle theorem, we could have figured out everything was equal, therefore proved they're congruent by every method of congruency that there is, including hypotenuse leg, which we haven't learned yet. Okay? Okay, the last one here, the last example, we know that vertical angles are equal. So that gives us that the angle at C is equal to the angle at C. We have that those two little pieces, 4 and 4 are equal, so there's a side. So we've got an angle and a side. Now, we don't know any other angles. And you may say, well, alternate interior angles are equal. But do we know that the alternate interior angles are equal? Well, you can't reach that conclusion unless you know that the lines are parallel. There was nothing to show that the lines were parallel. Therefore, we can reach no conclusion about A and D or B and E. And so really we can reach no conclusion there. I did notice in my teacher's edition I named a congruency, which I should not have done. And so this should be no conclusion. So that's a correction that needs to be made. Any questions on that? Angle, angle, side. All right. The last method of proving triangles are congruent is hypotenuse leg, and then you know automatically that that applies to a right triangle because hypotenuse and leg are parts of a right triangle. So when we look at hypotenuse leg, what we have is that this right angle is equal to a right angle, so that gives us an angle. And then we've got the very next side, very next side, very next side, very next side. Now, that gives us, and we'll write it in reverse order, looks nicer on the board. That gives us a side-side angle. And so side-side angle is not always true. So we don't prove it by side-side angle, but if it's a right triangle, my projector just went off. I'm going to pause here. Excuse me for the delay, and then I'll fix it and be back. Okay, we're back. There was a little lightning flash, and it made my projector go off. So we're ready. So when you look at the right triangles, then in right triangles, the side-side angle or angle side-side will work, but it has to be the hypotenuse in one of the legs equal to the hypotenuse in one of the legs. So we have a corresponding leg equal a corresponding leg. A hypotenuse is equal to a hypotenuse. We were dealing originally with a right triangle, so we can say that those are congruent. Now, A corresponds to D. That was both right angles. B was opposite the legs. The leg indicated with an inequality. So we look opposite the corresponding leg. So B must correspond to E. They were opposite corresponding legs. And then the hypotenuse, or the C is the one left, and the F is the one left, excuse me. So we have C is equal to F. So we would say that those two triangles are congruent by hypotenuse leg. We do not use angle side-side or backward side-side angle because it doesn't always work. It works only in a right triangle every time. It works every time in a right triangle. It works some of the time in non-right triangles, and we're not really going to try to explain the when it does and when it doesn't. You can play with those and figure that out, I guess. Okay, when we look at the next example, we have BD is equal to itself by reflexive, which gives us a leg equal leg. We know they're right triangles. You can see the right angle marks at the bottom. And then we have the 10 and 10. That's a hypotenuse equal a hypotenuse. So we have hypotenuse equal hypotenuse. leg equal leg, and we have the indication here that I'm making in green that it's right triangles. So the hypotenuse and leg of one right triangle is equal to the hypotenuse and leg of the other. A obviously corresponds to C, so C's first. The B here corresponds to the B there, so the B's second. The D's were both of your right angles, and so D would correspond to D. Any questions there? We have two right triangles in the next picture. We have this leg equal to this leg. We have the hypotenuse here equal to the hypotenuse there. Remember that the hypotenuse is the one across from the right angle. So we have the hypotenuse and leg of one right triangle is equal to the hypotenuse and leg of another. D was 90, B is 90, so B goes first. E, at this point, we really wouldn't know what it goes to. You can see that it's looks like it would go to A, but you really can't say that. We do know, though, that the C's are equal because they're vertical, so that puts C last, and then by default, E is the one that goes with, A is the one that goes with E, okay? Any questions on hypotenuse leg and angle side? Okay, we're going to look at the daily work on this. It says name two congruent triangles, tell how they are congruent. What we have is an angle of one triangle is equal to an angle of another. The very next angle is equal to the very next angle. The very next side is equal to the very next side, and so we have angle, side of this one is equal to angle, side of that one. Notice that the side is not included between the two angles, so it's two angles and a non-included side of one triangle equal two angles and a non-included side of the other. Therefore, the triangles are congruent by angle, side. When we name the congruency, A was first. It has here, so it goes with what has one arc over here, which is R. So A goes to R, okay? Because they both had one arc, showing that A is equal to R. So this thing got spun around, you see. B has two arcs in this picture. What has two arcs over here is the X. So B must correspond to X because the two arcs show that B and X are equal. So X goes in the middle. Well, the only thing left with R and X is H, and so we know that H must be the one that goes with C by default, okay? We just don't say top goes to top and left goes to left and right goes to right. You have to look at what's equal to find those corresponding parts and make sure that you name those corresponding parts in order, okay? All right, what we have on the next one is hypotenuse. These are right triangles. Hypotenuse of this one, 10, is equal to the hypotenuse of this one, 10. And this leg, 8 of the first one, is equal to this leg, 8 of the other one. So we have a hypotenuse and leg of the first right triangle is equal to the hypotenuse and leg of the second right triangle. So we can conclude that those two are congruent by hypotenuse leg, and we'll let you name that congruency. Now, we're going to continue on here with the first one. I'll shift this up and then rewrite it so we can see the conclusion that's going to happen. I just wanted a little more space. Remember, as we untangled this, we said A and R both had one arc, so R was first. We said B and H both had one arc. I'm sorry. Back that up. And I'm going to move my recorder out of my way. Let me slide this over so we can actually see what we're looking for. We'll do this correctly. B and X both had 2 arcs, and so X goes in the middle. You may have noticed I tried to attach B to H because I wasn't paying good attention, and that's easy to do. And then by default, the C went with the R. We said that they were congruent by angle, angle, side. Notice that it took, I made another mistake, excuse me. This is R first because A is equal to R. I guess I just as well start over with my color coding. All right, so we have one arc, A is equal to R. I'm sitting here saying don't mess up. It's easy to mess up, and then I'm messing up as soon as I say don't do it. B has 2 arcs, X has 2 arcs, B's in the middle, X goes in the middle. C was the last one, H is the last one. By default, C is equal to H, and so H is last. There we have it. I apologize. Notice there's 3 things marked. Triangles have 6 things, 3 sides and 3 angles. Now that we know that these are congruent, we can automatically say that the other 3 sets of corresponding parts are equal. So we can automatically say now that angle C is equal to angle H. We can say that this side right here that wasn't marked AB would be equal to its corresponding side of the other one, so AB is equal to something. And the best way to see where AB is equal to what is to look right here. That way you make sure you lined your parts up. See, AB actually goes to RX. So we named the congruency, and then when we go back and name these corresponding parts, we're going to name them exactly the way they should be lined up according to the way they're named congruent. And then we had another pair of sides that didn't have a mark. We had BC without a mark. And so we now can conclude that BC is equal to something in the other one. We had AB, I'm going to go ahead and put it in red, was equal to XR. We have BC is equal to something, and you may have a hard time knowing it, which one it is. Is it XH or is it HX or what? But you can look right here and see BC is the last 2 letters. So you just look at the last 2 letters. If we've named them congruent correctly, then we'll know that BC is equal to XH, you see. Name them in the same order that you named them in the congruency. Now, the reason that we can say that angle C is equal to angle H and segment AB is equal to segment RX and segment BC is equal to segment XH is corresponding parts of congruent triangles are equal. And that's a little triangle with an S in the middle. That's how I write triangles shorthand. But anyway, any questions on that? We're going to let you finish that yourself because you need that experience, okay? The odd ones, like number 3, don't forget all of the answers to that are in the back if you need to check your work. But we still encourage you to do the work on your own, okay? Now, we have some proofs. We have a proof where you give reasons only. We are going to get you started. I think I'll just get you started on that and then kind of leave you with it. Maybe it's been a while since you looked at perpendicular, and we may need to know how to write that in the notes. Started there. Okay? So we have the proof all set up, and so we want to make a note section. So we're going to take what we're given, mark it in the diagram, write statements and reasons derived from the markings in the note section. It says HX is perpendicular to XB. Perpendicular lines intersect to form equal adjacent 90-degree angles. To show that that's perpendicular, we mark that that's 90. And so we could say angle x is equal to 90 degrees, reason definition of perpendicular. And if I'm going to say definition of, then I need the word, and so I'm going to say hx is perpendicular to xb, reason given. And you'll continue uh, to write those, what you're given, mark it in your diagram, write statements and reasons derived from the markings in the notes section. Don't forget, when you get to triangles congruent, the only choices you have are side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg. If you're going to prove that two triangles are congruent, it's got to be one of those things. So number 14 is one of those 5 choices, right? Now, once you know they're congruent, you can say other set of corresponding parts equal because, and you should know the answer to that one. You may have a little bit of trouble with angle x is equal to angle b. It's not in the given, it's not in the diagram. You're going to have to use these statements above. So you're going to do something with those to come up with number 4. And you've got to think of everything that we've learned all year, including all of the properties of equality. Okay? So don't forget all of those properties of equality as you start trying to give reasons and a proof. Um, Give me just a second. Okay. So the properties of equality in this textbook are on page 22. That's in this geometry book. In the Algebra 1 textbook, they're on page 28 to 29A. Okay? So you might want to go back and look that up in that reference there. Okay? All right. Well, we got 2 proofs. We'll take a look at number 16. Remember, to do a proof, we're going to write the given proof, put the statements on the left, reasons on the right, draw the diagram. Take what we're given, mark it in the diagram, write statements and reasons derived from the markings in the notes section. So the first given statement said that angle x is equal to angle E. So we go to our diagram and mark that. Angle x is equal to angle E. Reason given. Anything else we can immediately conclude from that? Nope. So we go to the next given statement. It says AB is equal to GB. So AB, 1 mark, equal GB, 1 mark. We write what we marked. AB equal GB, reason given. So we took what we were given, we marked it in the diagram, we wrote statements and reasons derived from the markings in the notes section. Now what we want to do is look at what we're trying to prove. We're going to make that the very last statement in our proof, XB is equal to EB, and we need a reason for that. So our whole proof becomes to try to come up with a reason to say that those two are equal. And so what we want to do is think of everything we've ever learned that has the conclusion that two segments are equal. Well, we're going to have things like definition of a midpoint, divides a segment into two equal segments. Definition of the bisector of a segment, a line segment, rare plane that intersects a segment at its midpoint, but we know that that makes two equal segments. The isosceles triangle theorem gave us equal pieces. The bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. We had things like if two angles of a triangle are equal, the sides opposite those equal angles are equal. We had all those properties of equality, addition, subtraction, multiplication, division, substitution, transitive, all of those things. We have corresponding parts of congruent triangles are equal. We have opposite sides of a rectangle are equal. We have all of the sides of a rhombus are equal. All the parallelogram properties. And so what we think is, okay, could we prove that XB, I'm gonna highlight these. Could we prove that XB, that's this, is equal to EB because of the definition of a midpoint? Well, no, we couldn't do that because that's crooked. So definition of a midpoint's out. Definition of the bisector of a segment is out. Parts of a parallelogram are out. It's obvious that these are parts of congruent triangles. They're parts of triangles that maybe we could say are congruent. So when we think about all the ways to prove that two segments are equal, we're thinking it seems like the way this thing is leaning would be to prove it by corresponding parts of congruent triangles are equal. Corresponding parts of congruent triangles are equal. Some books today put CPCT to abbreviate that. Corresponding parts of congruent triangles, okay, CPCT. I'm fine if you put CPCT as long as you know what CPCT stands for. CPCT stands for corresponding parts of congruent triangles. Okay? Now, if I'm going to prove that they are congruent, if I'm going to prove that they're equal because they're parts of congruent triangles, then I have to have a statement that says my triangles are congruent. And I'm going to name the first one whatever I want to name it. I'm just going to call it triangle AXB. If I call it AXB, I need to line the other one up accordingly. It's obvious to us that X and E go together, and the B's are vertical, so it must be A and G that go together. So G's first, and X matched E, and the B's were vertical, so B is last. But I need a reason to say they're congruent. So no longer are we trying to find a reason to say XB is equal to EB. We've got a reason for that. CPCT, corresponding parts of congruent triangles are equal. We're trying to now find a reason to prove they're congruent. Now, so we're going to look at what we're given. We have an angle and a side. Now, looking at all the ways we're able to prove they're congruent, we'd say side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg. Now, it's not a right triangle, so that's out. They gave us an angle, so that's probably out. So it's between these three. Now let's see what we've got. We've got an angle here and an angle here, and we've got a side here and a side here. If I tried to go this way, I could turn it into an angle side if I knew that angle. If I knew that side, it would be an angle side, which we don't prove it by. If I went this way, I could get an angle side. Okay? So it's looking kind of like angle side because of the way that angle and side are located, right? Because of where that side is located in relationship to that angle, it seems obvious we're going to prove it by angle, angle, side, but we got to figure out if we're going this way or we're going this way. So let's go back and think about that. If we were try to go this way, we would need a mark on XA. And in the other triangle, if we were going to go this way, I'm sorry, by angle, angle, side, we would need angle A. And if I was going to go this way, on the other one, I would need angle G. So I would need to know that angle A is equal to angle G. If there was a way to prove that angle A was equal to G, I could say they are congruent by angle, angle, side, that direction. Any way to prove that angle A is equal to angle G? There's not. So we can't prove it by angle, angle, side, this direction. So we check the other direction. If I was going to prove it by angle, angle, side, this direction, I would need angle B to have an angle, then a side, see? And if I was going to prove it by that same direction, I would need angle B to have an angle, angle, side that direction. So can I say that angle B of the left one is equal to angle B of the right one? And you know I've got to name it with 3 letters. Can we say that angle B of the left one is equal to angle B of the right one? If we could, we could have an angle, angle, side. Well, we can because those are vertical angles. And we need to name those with 3 letters. So we said, hey, we're going to prove this by angle, angle, side. But to do that, I needed to know that angle B of the left one, which I've got to use 3 letters, XBA or ABX, XBA, is equal to angle, if I go X first, I got to go E first, EBG. And I knew that I could say that because I knew that they were vertical. Well, all of a sudden, to make a reason, we don't need another statement, which makes us feel like we got done. The way it kind of happened, we said, well, to say that corresponding parts of congruent triangles are equal, I needed to know they were congruent. But then I needed a reason to say they were congruent, and to say that I needed angle, angle, side, so I needed another angle. But I needed a reason for that, and the reason was vertical. And to say vertical, I don't need anything else. So all of a sudden, I don't need anything else to make a certain statement and reason, so it appears that I'm done. Well, to check that out, we've used the yellow highlighter through this whole course so far. We're going to check the statements and reasons from the bottom up. If I'm going to say corresponding parts of congruent triangles are equal, then I have to have congruent triangles. I'm going to say that these parts are equal because they're parts of congruent triangles. So I need this statement with this statement to make that reason. I have what I need, therefore this statement and reason are justified. So I go, this statement and this statement were needed. Now to say that they're congruent by angle, angle, side, I need an angle, and a side. Well, there's an angle, there's an angle, there's a side, so that I can say that they are congruent by angle, angle, side. So that's justified. So I go to the next needed statement. I need that as one of my angles. But if I'm going to say, notice this angle, angle, side, then what I see here is angle, side, angle. See, I prefer to go ahead and move that up there so that you have angle, angle, side, and I don't really care if the given's first or second. I want it in the order angle, angle, side. But if it's going to be angle the correct way, angle, angle, side, then let me do a little bit of erasing here to be real proper, professional, whatever. In the order that angle, angle, side really appears, then I need the vertical angle second because I've got angle here, my vertical angle, and then my side, see? So I'm going to put that really where it goes to match up. Some teachers may not care. I just like it all nice and organized. So we can say that these are equal because they're vertical, so that statement and its reason are justified. We go to the next needed statement, AB equal GB, and that's given. So that's all justified. The next needed statement, angle X equal angle E, that was given, so that's justified. So we've got our entire proof lined up. Now, again, we moved this one statement. So to make this look like angle, angle, side in the picture, then this is my first angle, and this is my second angle. So I'm going to make that statement in reason 2, and then we're going to put the side as statement in reason 3. That way we actually have angle, and then side in our proof. So it doesn't look like angle, side, angle. When we move it over, it looks like angle, angle, side. And then we're going to say that they are congruent by angle, angle, side. And then we'll say that those pieces are equal because corresponding parts of congruent triangles are equal. And we'll just shift that over into our proof. Any questions on that? Okay. We'll let you do the next proof by yourself. It is in the odd answers so you can check your work, but don't just write it down. Try to do it. Peggy filled her car up with gas last month 4 times. She put in 8 3/10 gallons, 6 7/10 gallons, 11 9/10 gallons, and 7 gallons. How many gallons of gas did she average putting in her tank? To find the average, you're going to take the sum of the items divided by the number of items. That is on page 66 of the algebra text. And we're going to leave that one for you to do, and that brings us to the odd answer solutions. Okay?